So welcome guys to today's tutorial. I'm excited because I know that you guys are approaching exams, and this video is going to help you to understand certain concept in physics. So I would advise you to take just get a paper or a book where you're going to be, at least you solve, then you compare with the answer that I'm going to be finding. Otherwise, enjoy the video. Let's the game begin. So let us go ahead and talk about vectors. So I've got a question which is saying the x component of a vector A is negative 25 meters and the y component is positive 40 meters. Part 1, find the magnitude of A. Part 2, what is the angle between the direction of A and the positive direction of x? Okay, so let us go ahead and try to see how we can solve this. Now the beauty part about this question is we are trying to find the magnitude of vector A, of which we have been given the x component of vector A and the y component of vector A. So meaning that we have got ax being equal to negative 25 meters and ay is being equal to what? It is positive 40 meters. Of which I know that for me to find the magnitude of any vector, we put an arrow on top or you put it in modulus like that. So you choose. It is given by the square root of the x component squared plus the b component squared. So in this case, the x component, it is negative 25. I square it plus 40 square it. So what are we going to get? So negative 25 squared is going to be positive. So you just say 25 squared plus 40 squared. So I'm getting the square root of 2225. Now what is the square root of? So that's vector A. So the square root of 2225, it is 47.16. Now 0.169. I want you to understand one thing. If I check the question here, this is in one decimal place, this is also in one decimal place, so I'm going to follow that. So my answer has to be in one decimal place. So vector A is 47.2 meters. That is the magnitude of vector A. To find the direction, before you even go further, I want you guys to know something. Before you even find the direction, I want you guys to know where the angle is going to fall. You should be able to know where the angle is going to fall before you find the direction. So we should understand one thing, that this is the xy plane and this is positive x. That is negative x. That's positive y and that's negative y. So if you are the angle you are trying to find, you discover that its x component, the vector, its x component is positive, the y component is also positive, then that vector has to fall in the first quadrant. In the first quadrant we have got positive, x also positive, so it has to fall in this quadrant. Remember, theta is given by tan inverse of y value divided by x value. So if I find the answer here, if I find the theta using this formula, the direction they are asking for is the same theta. I'm going to report my theta as the direction. If the x component is positive, the y component is positive, it falls in the first quadrant. In the first quadrant, if you use the formula theta being equal to tan inverse y over x, I'll get the same formula, I'll get the same angle. That is the angle they are looking for. Okay. Now, in a case where the x component is negative, the y component is positive, in this case, it's going to fall in the second quadrant. In second quadrant, we have got x negative, y positive, so it will fall in that quadrant. So when you solve using this formula, you plug in the values here, don't plug in negative. So put x and y to be positive, ignore the negative. Then when we find the answer, you will say 180 minus the theta. Simple, right? Then the third one, you can see the trend now. If they are both negative, then it falls in the third quadrant. In the third quadrant, when you solve the answer, ignore the negative, plug in the values, you find the theta. Then you're going to say 180 plus theta. Do not say 270 minus theta, no. Because this angle you are from finding, it is here. This is the angle. So we're trying to get the angle from this line all the way until it touches there. That's why it is 180 plus the theta and not 270. When you say 270 minus theta, you are finding this angle. So we do not do that. If the x component is positive, the y component is negative, what do we do? It falls in the fourth quadrant. Plug in the values here, ignore negative, plug in positive, then you say 360 minus the theta you have found. That is the angle we are looking for. Now we can solve this question. This question is asking us to find the direction. Now we should take note, the x component, let me just get rid of this. We should remember that the x component is negative, the y component is positive. Definitely, I'm from explaining this. If the x component is negative, the y component is positive. What comes in your mind? The angle falls in the second quadrant. So when I find my answer, I will say theta being equal to tan inverse of ay divided by ax. Okay, theta being equal to tan inverse. What is my ay? My ay is 40. My ax is 25. Ignore the negative. That's okay. Theta will be equal to, so you take shift tan, open brackets, 40 divided by 25. Close the brackets. So I'm getting 57.99, which is the same as 58 degrees. Now, it falls in the second quadrant. I said that if the angle falls in the second quadrant, what do we do? Okay, so it is 180 degrees minus the theta you have found. So 180 minus 58. What is the answer? So the angle they are asking us to find, it is 122 degrees. So that's the angle above positive x-axis. Okay, so the basic idea behind vectors is to know in which quadrant that angle is going to be. Okay, is the angle going to be in the first quadrant? When you use this formula, the answer you are going to find remains the same. You don't do anything with it. If the angle falls in the second quadrant, 180 minus theta. If the angle falls in the third quadrant, 180 plus theta. The angle falls in the fourth quadrant, 360 minus theta. As simple as that. Okay, that is it for this question. So I have got a linear motion question, and one of the most interesting question under linear motion. So let us try to read the question and then we see how we can solve it. So the question is saying a car traveling at a constant speed of 70 kilometers per hour, which is 19.44 meters per second, passes a stationary police car. The police car immediately starts a chase, accelerating uniformly to reach a speed of 88 kilometers per hour, which is 23.61 meters per second in 10 seconds, and continues at a speed or at this speed until it overtakes the car. Calculate the total distance traveled by the police car to catch up with the other car. So I'm going to have the data for just the car, which is traveling at a constant. Okay. So I'm going to have the data for just the car. What can we see from just this car which was traveling? So we can clearly see that it was traveling at, so the initial speed, okay, meaning it's 0, but the final now which it was traveling with, it is now, I'm going to use meters per second, 19.44. Or let's do this. Okay. Or let me start gathering data for the police. It will be easy for the police. So I have the police car. So what is happening here is the police statement starts from here. The police car immediate start. So initially, this car was traveling at a constant speed, passes the stationary police car. So the police car was at stationary, meaning that the initial speed of the police car is 0, but the final which it was moving with, it is now 23.61 meters per second. So it took about 10 seconds for it to catch up. Okay, in short, for it to move at this speed, not for it to catch up, sorry. For it to move at this speed, 23.61 meters per second, it took about 10 seconds. Okay, then for just the car, the only thing we know is just the speed, the V only, which is 19.44 meters per second. We do not know the initial speed. We do not know whether it started from rest or not. We don't know, so we'll leave it there. Now, one thing I want you guys to understand from here is this. Okay? One thing I want you to understand is this. For us to find the total distance, we have first to find the distance which was covered by the police car during this time of 10 seconds. Okay? During this time of 10 seconds, I don't know. So now I'm going to say the distance, I'm going to use this formula. Oh, let me do this. The final squared being equal to the initial squared plus 2AD. So the final, okay, of the police, we know that is 23. Okay, 23.61 squared being equal to the initial is 0 plus 2. But I don't know the acceleration. But I want to find the distance again. So now we know that we have this information here. I can use that information to find the acceleration using this formula. So the final is 23.61, initial 0, acceleration I don't know, the time is 10. Okay, so now I'll have 10a being equal to 23.61 divided by 10 divided by 10. Therefore, acceleration will be equal to, it will be 23.61 divided by 10, which is 2.361 meters per second squared. I'm not going to round it off. Let me just shift it to this side. So the acceleration now is 2.361 meters per second squared. Simple, right? After finding the acceleration, I can now plug in here. I just want to find the distance it traveled, not the distance it used to catch up, no. But this is going to be the distance, because the question is saying the police car immediately starts a chase accelerating uniformly to a speed of 23.61 meters per second in 10 seconds and continues. So we are going to find again the distance it continues from there now. Okay, so we have 23.61 squared being equal to 2 acceleration 2.3 361 times d. So 2.361 times 2, it is 4, this d. So divide it by 4 point that, even here. So this is squared, let's not forget. So these will cancel out. What will be our d? Our d will be equal to 23.61 squared divided by 4.722. I'm getting 118 meters. So this is the distance it traveled during the first during 10 seconds. But again, from there, after it reached at this distance, it continued. That's why the question here continues to say, and it continues at this speed. Okay, so it continued at that speed. One thing I want you to understand again here is, now we have two things. So now I can start talking about the car alone. So the distance covered by the car, is going to be the velocity. Since it was at constant, the velocity is equal to distance over time. If you have been given just the speed, okay, if you have been given just the speed, I want you to take note that you can use this formula. So the distance will be equal to v times t. This is for the car. So if I plug in the values, the distance is equal to, what is the velocity? 19.44, okay, times t. This is the distance covered when it was constant, now, like that. After finding this, another thing that you have to take note is this. After it continues, the distance is going to be the same. This distance and the distance it traveled after it continued at a constant speed for it to overtake this car is going to be the same. So I'll use the same formula again. V is equal to d over t. Therefore, the distance after it continued, now the police car, it is v times t. So it continued with the same velocity, which is 23.61 times t, which I don't know. Okay, now I want you to understand one thing. Okay, I want you to understand one thing. So now, after finding this, what comes next? Okay, remember we had a distance of, this is the distance it traveled before catching. So in short, when I add this distance and this distance should be equal to that distance. What do I mean? The distance for the police, this is the distance for the police, and that is the distance for the police. Oh no, this is the distance for the police. So you add the distance for the police should be equal to the distance of the car. For you to overtake, the car, the distance traveled by the police and the distance traveled by that car should be the same. So we know that the distance traveled by the police in just 10 seconds, it was 118.05. Okay, then the distance traveled when it continued, now after that 10 seconds, it is d is equal to 23 times 0.61 times d. So this should be equal to that. So now when I add this, it will be 19.44 should be equal to, or it's times t here, should be equal to 118.05 plus 23.61 t, like that. So what happens now? Let's see what is going to happen. So our goal now is we want to find the value of t, okay, of which we know that t is not going to be negative. I want you to understand that it's either, you just choose. Sometimes when you're confused, like in this case, you can start with n. You can either add this, okay, with that, or you can make it the way I've made it. But the best way for you not to get a negative, you do it like this. You can start with 23, although it's the same thing, only that the time is going to give you negative, then you ignore it. So it's going to be plus 19 point, okay, which one am I talking about? So I'm talking about 23.61t should be equal to 118.05 plus 19.44 t. Now you can shift this to the other side to find the value of t. So we want to find the total time it took for it to overtake. So it will be minus 19.44 being equal to 118.05. So what will be the answer there if we do 23.61 minus 19.44? So 4.17. So we have 118.05. So divided by 4.17, 4.17. So therefore t will be equal to, okay, so t now will be equal to 118.05 divided by 4.17. So it is 28.3 seconds. Now this time, this is the time which was it took about 28.3 seconds for you to overtake it. So now remember, we had this formula where we said d is equal to 23, okay, 0.61 times t, and this distance, it was about 10 seconds. So if I find that distance, I add it to that distance. That is going to be the total distance it took for the police car to overtake the car. So I'm going now to add it. I'm going to say, first I need to find that 23.61 times the time is 28.3. So 28.3 times 23.61, that is 66.84. So the distance is 66.84. So now the total distance should be 118.05 plus 66.84, which is going to be we have 118.05 plus 66.84, which is 184. Okay, are we finding the correct one? Can this be 66? No, this is not true. We are doing times here, we are not adding, but we are multiplying. So 23.61 times 28.3, 668, sorry. So the distance here is 668.3 So 668.16 we add there. So 668.18 plus 118.05. Okay. 118.05 plus 668.16. So the total distance should be 786.21 meters. That is the total distance. So you can follow through the method which I've used. The most important thing is you need first to find the distance traveled in 10 seconds. That was 118. The next thing is you need to find the distance it traveled after that 10 seconds. So for you to find that distance, you need to understand that the distance traveled for the 19 meters for the car which was traveling at 19.44 meters per second is going to be the same as the total distance traveled by the car. That's the reason why I had to add those two. Okay, I had to add. So if you add, it's going now to give you the 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 distance, the time first. So that time you come back and plug in on that other distance, then you add to the distance for 10 seconds. Then you'll be able to find the total distance traveled for it to catch up with the car. So let us talk about elevators. So one thing we should know about elevator is let me first draw a diagram. If that is my elevator and that is a scale, so they are saying a student carrying a 5 kg. So here is a student carrying this package which is 5 kgs. One thing I want you to understand is that when we're talking about elevator, when an elevator is going up, the acceleration is positive. When an elevator is coming down, the acceleration is negative. Okay, so the scale will always lead the normal force. Okay, but the force pointing downward is mg, then this is the normal force. Okay, now the question is a student carrying a 5 kg bag, put it on a plastic seat hanging in an elevator that accelerates upward, meaning acceleration is positive, with an acceleration of 1.75 meters per second. What is the apparent weight of the bag as shown by the balance? So what it means is what is the scale going to show? Okay, so the scale is always going to give us the normal force. So you need to make the normal force as a subject of formula and find. So you say the summation of forces in y direction. We have got the normal force pointing upward minus mg pointing downward. According to Newton's second law, replace this by mass times acceleration. So mass times acceleration is this, that. Shift mg to the other side, you have this. So it will always, the elevator will always lead what? The normal force. So meaning that the formula which we use under elevator is this. This is the general formula. So you can factor out m, you remain with this. What changes is the acceleration. If an object is moving up, an elevator is moving up, acceleration is positive. An elevator moving down, acceleration is negative. But when it's moving up, positive. Down, negative. In this case, we've been told that it was moving upward, the acceleration is positive. Then you plug in the values. So you have that being equal to the mass is 5, acceleration 1.75 plus g is 9.8. So the normal force will be equal to, we are going to have 1.75 plus 9.8 then times 5, which is 57. So the weight force is going to be 57.75 newtons. That is the force that the scale is going to weigh. Okay, so I've given you everything I think on elevators, unless if any questions come under elevators, you just follow the same step. When it's going up, the acceleration becomes positive. Because it's going down, the acceleration becomes negative. As simple as that. Now let us talk about Newton's laws of motion. So the question is saying a box is pulled along a floor at a constant speed by a force F applied at 37 degrees with respect to positive x-axis. The force of friction between the box and the surface is 20 newtons. The box has a mass of 30 kgs. What is the work done by the pulling force if the box is moved 5.0 meters? Let's come up with a free body diagram. It is 10 marks, and remember, for us to get these 10 marks, we need first to analyze the question, come up with a free body diagram. We have the box, which is being pulled at an angle, and the angle here is 37 degrees at the force F. The friction force, it is there, which is 20 newtons, which is opposing the motion. The mass is 30 kgs. So the next thing that we have to do is to start now working around with the forces in x direction. So the distance covered or traveled by this box, it is 5 meters. So the summation of forces in x direction, okay, when something is moving at a constant speed, take note here, when something is moving at a constant speed, the net force is 0. So this will be replaced by 0. So in short, the acceleration is 0. So the summation of forces in x direction, the forces which you have, I have got this F has got Fx and Fy. But in this case, the object is moving in x direction, so I'm going to use Fx. So it is Fx, okay, minus the friction force which is opposing the motion. Replace this with this 0, then Fx is equal to or times that. Shift the friction force to the other side. So this is Fx, guys. So it will be equal to Fx. And we know that the friction force is 20, meaning that the Fx is also 20. So Fx is basically also 20 newtons. Now, after finding the Fx, because I'm interested in Fx because the question is asking us to find what is the work done by the pulling force. Okay, so the work done by the force is the force itself, but which component of the force? The force and the distance is in this direction, that is 5 meters. The force and the distance should be parallel, not perpendicular, but parallel. They should be going in the same, they should be in the same line. So I'm going to use Fx times d. The work done by the force, what is Fx? Fx is 20. Okay, Fx is 20. The distance is 5. So the work done by the force is basically 100 joules. You might be wondering, why have we not used the angle? If you want, you can still use the angle. Okay, but still you end up having the same thing. So this question was just direct, basically. It was just direct. But it will, okay, if this was moving at a certain acceleration, it would have been different. Okay, and in a case where would have been given maybe the mu value, it would have been also different. Okay, but for this type of question, this is the answer. That is it. So I know that you are enjoying this video, but I just want to show you something. As you are preparing for your exams, I want us to look at something different. So looking at the paper that you are watching right now, the full solutions, you can find them because it is for 2024, and physics 1015 2024 is here, or the solutions from question 1 up to the last question, they are here. Okay, so you can access this using our website. Just log in there. If you have not yet subscribed, I would advise you to subscribe. Remember, physics, they like repeating questions, so this is going to help you to prepare for your exam. Not only this paper that we have, but we also have other papers for the same paper, for the same physics 1015 2023 we have, 2022 we have, even 2021. So it's also here. So the best way to prepare for your exams, if you look at these papers, they have been repeating, just know these papers, watch our videos, they will really help you. Okay, so let's go back to our questions. Okay, so in this one, we are now going to talk about I can call it freeform motion. Yes, we are going to talk about freeform motion, but I also have a certain question on top there, which we are going to start with, more like a wrap up just. So the question is saying convert 0.04 nanoliter to gigaliter. So it is something that is simple, and in most cases I think they do give to say 1 giga is equal to maybe 1 nanometer. I don't know, but they give. What you need to know is that one thing we need to understand about these things is that 1 nanoliter is basically equal to 10 raised to the power negative 9 liters. Then at the same time, in 1 gigaliter, it is also 10 raised to the power 9 liters. So it is more like the opposite of each other. So it is better for us to come from nanoliter to liter than from liter to gigaliter. You know what I'm trying to tell you? What I'm trying to tell you is we can use dimension analysis to say 0.4 nanoliter. So now I come first from nanoliter to liter. So in 1 nanoliter, I have got 10 raised to the power negative 9 liters. So now I can clearly see that nanoliter and nanoliter will cancel. I have got now liters. Okay, so now we are coming from liters to gigaliter. So we know that in 10 raised to the power 9 liter, we have got 1 gigaliter. So these now liter and liter can cancel out. So I have 0.04 times 10 raised to the power negative 9. The answer I'm finding is 4 times 0, or 4.0 times 10 to the power negative 11. Then divide that by 10 raised to the power 9, which is 4.0 times 10 raised to the power negative 20. So that is the answer. And sometimes you can also find this without a calculator, guys, because you shift this 1 2, so it's going to be 4.0 times 10 to the power negative 2. So again you are doing times 10 to the power negative 9. Then if I shift this one, it's basically the same as 10 to the power negative 9. So it's like 10 to the power negative 9 and 10 to the power negative 9 to give you 10 to the power negative 18. 10 to the power negative 18 times this. Okay, So it will give you 4.0 times 10 raised to the power negative 20. So now that one, it is in gigaliter. Okay, so that is it for the first one. But now the main purpose of this video, it is question B, which is saying a ball is rolled off a horizontal cliff with an initial speed of 11.4 meters per second. It falls a vertical distance of 15 meters per second, or 15.5 meters into the lake below. With what speed does the ball hit the water? Okay, so from the information which we have, let's assume that this is the cliff and the ball is rolling there. We know that the initial speed we have been given. Okay, that is the initial speed. So the initial speed we have been told it is 11.4 meters and the distance is 15.5. What else do we know? We do not know the time. We need to choose the formula which is going to help us to find the final speed without time. So it is the third equation. V final squared is equal to V initial squared plus 2a. Now we don't use a because it is under the influence of gravity, so it's g, then times h. H in this case you can say is d. It's fine. V final we don't know. The initial speed is 11.4. You square it plus 2. It is going down. G is positive. Okay, the distance, which is the height, 15.5. So we have, I'll start with 2 times 9.8 times 15.5. So I'm getting 303, then plus 11.4 squared. So I'm getting 433.76. Now if you get the square root both sides, so V final will be equal to the square root of this is 20.826. But this is in one decimal place, so I will leave my answer to be 20.8 meters per second. That's the answer. So this question comes from free fall motion, like I've said. So that is it for this question.